Good morning, everyone. It's my pleasure to talk to Minnesota Geotechnical Society. And I never really talked to you folks. I'm glad to know you guys are building a really good society. And so what I'm going to talk today is basically related to some work I have been doing in the past decade here, basically in Michigan Tech. So the work I'm going to talk is about engineering waste rubber to better roads. So what I'm going to do, so first I'll start with how much tires we have. So basically in the US, so basically annually we throw away about 4.5 million tons of tires. So 4.5 million tons. It's a pretty big number. So where those tires go? So of course you can say so a lot of the tires have been burned, basically used as a tire derived fuel. You can see almost 37%. Those being basically use that for maybe to generate the power or use that maybe in cement production. But there are also about 14% are being landfilled. So basically land disposed. So basically that's pretty significant. In a few years back in Hopeton here, basically we buried about 250,000 tires basically in the ground because there's no way we can really somehow effectively recycle it. So anyway, so there are 24% of all the tires generated used as ground rubber. And out of the rubber, of course, you can use that for mulch or sport surface and asphalt. And of course, you can see here in asphalt really only occupy about 4.2% of the entire tire we basically are using while we are generating. So basically, this data is pretty new data. Okay, in 2020's data. So it's basically our goal is trying to save the materials really being disposed in the landfill, and also trying to maybe get some market share into asphalt. So basically, that is basically our goal. And one thing I really like to talk today is basically, just to show some experience we have basically on the field applications, field experiments. So basically some of the work we have been doing. And then we are going to just briefly take a look at some of the lab research work we're doing, and also the modeling work, and also give a really brief summary. So basically, the first one I like to really talk about is about subgrade applications. So in the subgrade applications, then we'll talk about use the rubber materials in pavements, and also the rubber materials for pavement maintenance. So basically, the first one is about subgrade. So back when I was in Texas, I spent 2 years in South Texas, and of course later on worked with other industries, basically trying to recycle tires. You can see this tire here. This is in South Texas, basically on the U.S. and Mexico borderline. There were a lot of illegal tires also. Basically, people just dump the tires there and they just don't do anything. So eventually, of course, the city, of course, also collect a lot of tires. So basically, eventually those things are the tires are moving really to the landfill. Of course, just bury the whole tire in the landfill is basically you are wasting a lot of space. And also that's basically the major thing about space. And of course, waste a lot of natural resources. Of course, the tires are something valuable if we use that correctly. So one way we are thinking to use and to build all the tires, you can see there are 20, 30 tires together. We build it with the steel wires, and then basically bundle those things together, almost like a block. All right. So basically, we have so many different blocks of tires. Then basically, we are building all those things together. You can see a little bit far here. You can see in the corner. You can see basically this is a wetland and swamp areas. So basically, and of course, it's also close to the landfill. So basically, there's a road needed So basically, we eventually were thinking, well, we'll just use this as a subgrade, and we just on the top we just build a few feet of sand gravels, and then use this one as a road for the landfill. So basically, that's basically the starting of this project. It's pretty basically, of course, I'm not promoting to use this type of technology, because this one, you can imagine, you bury a lot of tires, really basically whole tires underneath the ground. All right, this is one way. Recently, this is just this summertime in Michigan, we are actually starting doing other type of trials. You can see this is whole tires, and this big tire, this is much bigger than auto tires. It's more like tractors or big trucks, the tires. Basically, we are, and this area, basically this project site here, they have pretty soft soil. This soil you can see on the dark, you can see over here, it's pretty dark here. It's a really black soil, really nice nice soil here. But then the problem is it got a lot of settlement. So over the years, this road just continues sinking. So basically, you know, of course, the county has to do is basically, well, add a layer, okay, add another layer. Over the years, you add a lot of layers. This just still keeps sinking. So basically, right now, so basically, they basically trying to do is replace the soil here, and they use whole tires, layers of whole tires. Right now, this is the first layer, and then of course after this is settled, you know, placed together. So basically, we fill with gravels. All right, this is basically it's least expensive aggregates they can get in this area. So basically, filled in, compacted, and then basically add another layer on the top. So basically, for example, this one is almost finished up, and then add another layer of tires on the top. So basically, of course, this is not really necessary to the best way to use tires, but this is basically showing the one way, you know, we can effectively, you know, treat the areas, you know, trying to avoid those settlement. So this is one way we're dealing with. So basically, this is about subgrade. Of course, I did not show is basically this on the side. All right, on the side we have two rows of tires. In the middle, we basically put the tire chips, and those tire chips basically is anywhere about I would say between 4 to 10 inch long type of tire chips. So basically, bury those things there, and tires, and then a layer of gravels, and then tire, a layer of gravels. So basically, build up in the middle. So in this way, of course, we want really have really, you know, relatively good drainage in this area. So basically the long-term goal is, you know, we want really see less of settlement here. So basically this is subgrade. Now, next one I really want to share is pavement surface layers. So basically now in pavement surface layers, of course, we cannot use whole tires. What we are doing here is use a rubber part of tires. So basically we have processors to cut tires and get rid of them. Well, they take out the steel wires. The steel wires actually are kind of very valuable, because with currently the steel price going up, so basically they can sell with pretty good price with the steel wires. Of course, they melt the wires into a big chunk of iron. So basically, that is one part. Of course, so we are basically have interest basically in the rubber part. So basically, the rubber has been being engineered to smaller pieces. So roughly anywhere from 30 to 50 mesh size, or actually to 16. So basically, so coarser size. Because the smaller particle size, the more expensive the processing would be. So basically, that is basically one project we are doing here. So this one is about 2016. We did basically starting some work at home. So here is basically very close to campus here in Michigan Tech. This place really is called Keweenaw County. And so basically in this over here, basically US 41 is passed through here. This one is called Gay Mohawk Road. So basically we're starting here to build about 5 miles roads here. And so basically this, of course, you know, we have 3 sections of paving. So the first section from here, basically all the control asphalt mixtures, basically everything here is the conventional asphalt mixtures. Basically the regular dense mix design we usually are using in Michigan, which is also very common in Wisconsin and Minnesota. So I know Minnesota is using a lot of the similar designs. So the construction basically, of course, is going on here, but really the asphalt plant is about 15 miles away, maybe 10 miles away. So of course, for this project, the asphalt are prepared in a plant earlier on with some rubber in it. For example, the rubber content was around 12% of the asphalt. So when the asphalt was brought to the site, so basically they are, start to inject it to the mixer. You can see this kind of dark color part in the asphalt plant. So in this way, of course, we can produce pretty consistent, high quality asphalt mixtures. So this is one of our projects are doing. And also another thing I want to mention here is, because this one was really kind of early time of the development we're doing. So basically one concern from the government was the emission come out from the plant. So for example, from here, you are going to release some kind of some odors, emissions. So basically, we also did a research work, basically trying to measure the amount of odors come out from the plant. So basically, we measured everything. So basically, all the chemical compounds. So everything eventually, will meet the requirements of Michigan environmental quality. So basically, that's so basically, since then, if they are using the similar design as we are using, so they don't really have to apply for a special permit to conduct such rubber asphalt production. Now, in the Kuna County in this project, you can see basically this is this area is rubber asphalt section. You can see, so basically construction was pretty smooth and pretty, so we did not really see much kind of a significant difference compared with conventional asphalt construction. And also, of course, so right now, if you go there, you can still see the signs. So basically, was this project is partially sponsored by the Department of Environmental Quality, and we also said this is also rubber modified asphalt. So this whole section here says hot. So basically, that really means hot mix asphalt with rubber. We also have a section called warm. So basically, warm asphalt with rubber. Right. So basically, there are a few sections. So after right now, so basically 6 years passed. So almost 6 years. So the road condition is still good. So that's basically, really thin overlay is about 2-inch overlay. So basically, the situation still looks really good. So for now. Another project we are doing, basically this one is different. So all the project I'm talking here is basically there are some kind of uniqueness. So this project is in Kalamazoo. The asphalt plant is in Battle Creek, which is about 30 miles to Kalamazoo. So you can see in the plant, basically this is the illustration of the plant. Basically the uniqueness here is, in the dryer mixture here. So instead of just pump the asphalt to the dryer mixer, we basically, this is of course, we always do that. So basically rubber is not in the asphalt though. Rubber instead is basically through the cold bin, basically in the plant, in the this area basically supposedly we normally input the recycled asphalt mixture here. So basically RAP. The recycled asphalt is really the old pavements, right? The old pavements really goes here. So basically being feed to the dryer mixer. And when the dryer mixer meet with aggregates, new asphalt together, they blended well. They are basically being elevated to the silo, to the storage silos. Then basically this asphalt mixture ready, right? So basically you can ship that to the job site. So basically we're here. So this one right now we are using this bin as our ground tire rubber bin. So basically the rubber being fed from here also along with the recycled asphalt pavement materials. So in the plant, of course, you can see here is, this place here, we drop with with recycled asphalt, so wrap recycled pavements. And then over here, basically directly drop the rubber materials. And of course, we align, how much percentage we need. We, for example, for this case, we say, okay, we are want to 18%. So basically, with whatever amount, you basically, through the belt here, through the belt here. So basically, you can see it's going to be elevated back to the dryer and a mixer, right? So basically, that is this one, of course, is a process we call it maybe so-called dry mix. Earlier on, you said that one called a wet mix. The reason wet is because the rubber is already in the asphalt. So this case, rubber is not in asphalt. Instead, it's going to be feed to the dryer and mixer directly. All right, this one is basically the uniqueness for this project. All right, so for this case, you can see for this project, you can see the rubber we are using. For this rubber, we basically engineer the rubber before we are using. So the rubber we are using roughly, for example, in this type of materials here, you can see 62% roughly are rubber. And we also let the rubber absorb some kind of asphalt. So basically this asphalt is about 22%. So when the being absorbs the asphalt, basically the rubber is going to swell. So basically they are going to change some of their features. Then basically we add some fillers, so blend it well, so that the aggregates, and then basically the particles of the rubber are not glued together. Otherwise, it's going to be probably a good chunk, so you cannot really separate it. So right now we have a filler together. So basically you can see we are having kind of a granular type of rubber materials with a little bit of asphalt and fillers. All right, so basically in the construction, because of the process we just showing you, so roughly we are doing the construction. You can see this is the beginning of the section of the project. So basically things going pretty well. The only thing, of course, you can see this type of a mixture is kind of a sticky. It's kind of sticky, but you don't really notice much. So basically this type of rubber is about 18% application rate we're using. With good aggregate gradations, we're using gap graded design for this case. And the thickness is only like 1.5 inch thick for this structural overlay. So this is basically the project has been showing up, pretty good. And now I'm going to talk to you about third project we did. So third project, so going back to the north again. So right now this place is in Dickinson County, which is about 2 hours from Houghton, and it's also in Upper Peninsula here. So this project, so basically is along a lake here. The lake, if you pass this lake, basically is Wisconsin. All right, so basically we are, this road here, basically we is a full depth reclamation. So basically we are recycling the base, everything from subgrade. So basically, and then blended things well, and then basically we are after the subgrade ready. So basically we are putting 2 inch of base asphalt. So it's a 2 inch here. So when the 2 inch are constructed, of course, then we basically pave the second layer here. So the second layer is being constructed. Of course, you can see this line here. Second layer is not ready yet. So second layer is about 1.5 inch. All right. So basically, this thick pavement is pretty thin, And now the difference here is this also we have 3 test sections. The 3 sections, one, of course, conventional designs you have using in the past many decades. The new thing is we have one section is conventional underlayer, and then the new is basically rubber asphalt on the top layer. And another, of course, underlayer also rubber, and on the top is rubber asphalt. So basically, we have 3 type of combinations. So basically, this project was completed. So right now, almost 3 years. So basically, last week I went there. Basically, I checked it. So basically, everything still looks pretty good. There's no cracks, no rotting. So basically, things is going pretty well. All right, I'm going to talk about my 4th project. I want to really show up here. So now let's go to south again in Michigan. So this is a road basically in Kent County, next to really close to Grand Rapids for this site. So basically this site, of course, this picture you can see is before the construction. We already closed the traffic, all right? We closed the traffic. This is a heavy traffic road, 5 lanes. And you can see from the picture, you can see there are tons of cracks and potholes, and a lot of them joints, cracks. Of course, this is the center line joints, which really got a really significant cracks here. So basically, our goal for this project, of course, is trying to what we can do with it. What kind of the mixture we should use. So according to this traffic, so we basically have to use modified asphalt. All right, modified asphalt. Basically, most of the time we say polymer modified asphalt. Well, of course, polymer modified asphalt normally is more expensive than conventional asphalt. So basically, in this design, we are doing the 3 lanes on the left hand. So basically, 3 lanes on the left. We basically are using rubber asphalt, and then the other 2 lanes we're going to use polymer asphalt. Well, our plan is we want to really see if the rubber asphalt is going to perform as well as polymer modified asphalt. Well, we have lower cost, right? So basically, that is a project we have been doing. So construction has been finished up. So it looks like things are going pretty well. Of course, you can see some kind of white marks here, which is basically we take some cores, we basically cut some samples out. We are doing some extensive amount of lab testing in-house. So basically, this is our Kent County project. And so we have quite some of the overlay type of work we're doing. So next year, we are going to have 3 more projects to be paved. And so as our experiment. And each of the tests, of course, you can see each of those things, they have some kind of uniqueness. See, they are not all the same. So my next thing I want to really check to show you here is some of the chip seal project we are doing. For the chip seal project, so this year, we have been doing a rubber chip seal. Basically, we have our goal this year was 100 lane miles. So I think this year we already did quite a bit. You can see on the documents are showing here. There are 1 section road, 5.1, 2.4, 11, and we have a lot of the project in different locations. So we piecemeal to 100 lane miles. And I want to really show you some of the things we have been doing. So the chip seal, of course, we all know that chip seal is not new at all. But what we are doing here is we are not really doing conventional chip seal. We are going to do the hot rubber chip seal. What really that is we are using hot rubber in lieu of emulsions. So in the past, for example, Minnesota, you have a lot of emulsion chip seal pavements. And because I know that I had a project working with Minnesota DOT and local road organizations, basically on the chip seal. Basically, this chip seal is different. So basically, we are doing is we are processing our rubber. So right now, the rubber has been shipped here. So we are let rubber react with asphalt. All right. So react with asphalt, and then basically let the asphalt sit here for a while, and basically we call curing. After that, it was ready. So basically, asphalt will be shipped to the site. All right, shipped to the site, basically road site for construction use. So basically, now you can see this rubber asphalt is going to be hot, and there's no water, and also have very good viscosity, because the rubber, basically we are including about 12% of rubber in the asphalt, which makes the asphalt has really good viscosity. And of course, when we are preparing the sample material here, our temperature for this type of material is pretty high, so that we want to make sure the asphalt can be pumped out easily, especially over here. You can see over here, this is a distributor truck. Distributor truck basically is asphalt tank on the top. You can see barely you can see because the vapor come out. And so basically this one distributed the asphalt to the pavements. This is the existing pavement. You can see on the left on the picture here. The pavement is really in really bad conditions. So basically our goal is to spray the hot asphalt on the top of the pavements, and then later on, just spread a layer of aggregates, and then just compact it, sweep it, clean it. Now the pavements will be ready. So this is one popular way for pavement maintenance in a lot of states, right? So basically, you can see basically the spring, the continue going forward, but of course this is a vapor here, right? This is a vapor. This is not really smoke. So basically, vapor is going on because the pavement is relatively cooler. So basically, when you hot things spray on it, so basically you generate vapors. Now, so basically, the next one we are going to spray aggregates. You can see the aggregates basically being sprayed on it. So later on, of course, you compact it. Now, because this is rubber asphalt, right? Asphalt on the road. So basically, you are going to generate a pretty good thickness of asphalt. You seal the cracks basically with the aggregates being spread on it. So basically, you are going to have pretty good rough surface. So basically, applying chips, of course, later on, compaction, clean up. So basically, the construction will be ready, right? So basically, we expect this type of application will make the road last quite a few years longer compared with conventional conventional emulsion-based chip seal. All right, because the conventional chip seal, you are using emulsions. The emulsions roughly have 50% of water, and with that, of course, and also your spring rate normally is pretty low. So basically, that means liquid asphalt really being effectively applied on the roads. So basically, that's maybe one reason. So anyway, for this type of chip seal, so right now, of course, this is only our very beginning of our testing. We don't really have really good amount of results yet. But prior to this one, we did a project in Kalamazoo County, as you just mentioned earlier on. We basically use a similar asphalt we prepared, and then basically spray in about 3 lane miles of a road in there. So basically, the pavement looks pretty good and rough and very seems to be very durable, right? So basically, that's our first trials. And then after about 3 years, we have this type of applications. And that is tips. Now, I want to really briefly show you maybe just some of the laboratory work I have done here. So this is samples. You can see these are a lot of samples. Basically, these are all chip seal. You can see a chip seal only a small thin layer on the top. And then, of course, we have some existing pavements also. So this basically, we test a lot of chip seal in our lab. Of course, some of the chip seal are from Minnesota. I wanted to show you one thing is basically about the performance testing we're running here. So we call this one low temperature performance testing with the disk shift tension test called DCT. So basically in this test, basically we're trying to understand how much energy we need to crack a sample. You can see this is a cylindrical sample. We cut 2 holes and then create a notch here. And then basically we're applying the force in the hole and then horizontally trying to crack the sample, right? So basically, we want to know how much load we applied and then how much distance we really pulled. So that's the reason we have a load versus displacement chart here. So basically, we are going to monitor the load versus displacement. And then basically, on this graph, you can see we have 3 groups of samples. And HMA, hot mix asphalt group, we have 3 test samples. We basically test it. You can see the results looks pretty consistent. And then we basically find out the areas underneath the curves. Of course, we can do integration. Anyway, so basically get those numbers here. So basically that means how much energy we need to crack a sample. For example, 476 joules per square meter or whatever, 579. So basically the other 2 curves are rubber materials. So with some rubber. So basically you can see rubber asphalt, of course, significantly improve the crack resistance of the materials we have. So basically this is our test sample initially in Keweenaw County, the first project. I'm going to show you Another project, this one in Kalamazoo County. You can see this same sample, right? Similar setup, 2 holes, notch here. So basically you're doing you're cracking. So basically the conventional sample here, for example, running about 400 joule per square meter, right? This is conventional sample, conventional design. We tried a lot of other testing. For example, you can see all the greens. The greens basically are the samples we are preparing with rubber asphalt. You can see it roughly is about 1200 joule per square meter. That's pretty good, right? That's basically almost 3 times higher than the fracture energy required to crack the control asphalt or conventional asphalt. That's really showing us at even this low temperature, our design really improved the low temperature crack resistance by 3 times, or at least 2 times. So basically, that's basically give us more confidence so that we can use these materials on the roads. Now I'm going to show next one is basically some of the effort we're doing in the modeling. Of course, that's basically in the modeling thing, we're also trying to show a similar approach like what you have seen earlier on. We are doing the similar test again, okay? DCT test again. So again, the sample look like here. This before the testing. After testing, it's going to be cracked, right? Now, in the modeling work, basically we are trying to show some kind of demonstration here. You can see what's the geometry of the sample look like. And each particles, of course, of the stones we modeled with something, with a group of elements together. And this is from the side view, and you can see from the top view basically is almost like 2 dimensions. You can see here because you only see the top surface. So you have a crack, you have a notch here, you have 2 holes, then you apply load, right? So right now for this case, the load application would be vertically. So basically during the testing, we can monitor the displacement in any points. And also we can monitor the contact force on any points also. I just want to really briefly show you what this look like. All right, so right now I have 2 pictures here. So basically on the left-hand side, so basically is the samples without rubber, and which is conventional materials. Now the right-hand side basically is asphalt mixture with rubber. So basically we have some rubber particles inside. So now we are trying to do the simulation, basically trying to crack sample. You can see when I crack a sample, you can see on the left-hand side, you can see the crack grow, and then basically eventually crack really quickly, right? So basically right now the sample basically, meets a certain criteria. Basically the sample, basically cracked, right? This one is bad now. Now the second one you can see it's basically crack more width, right? You basically can open a lot of width until it's really complete crack. And now you can also take a look at the crack route here. So the path here, you can see the path is going almost a straight way to the left, basically crack it. Now the other sample though, with rubber, you can see because rubber there, so basically the crack has been rerouted to some locations and they are not really crack all the way to the left. So basically that's the reason, and this sample also carry more of the strain. So we allow more deformation until it's crack, right? That's basically one of the fracture paths we have shown here. I'm also trying to show you is our contact force change. What's that development look like? Again, left-hand side is without rubber, right hand with rubber. All right. So basically, with a crack happening, you can see on the left-hand side, you can see the crack happening, really quickly to the left, and with significant stress concentration over here, of course, on the contact force change. Basically, that means a lot of contact force being generated here. So basically trying to crack the sample. Now, the other one, so basically you saw the process earlier on. So basically the contact force change actually has been kind of being rerouted to different locations. So basically delayed the some of the contact force being generated. So therefore, this sample actually is survive a little bit better. So that is basically from a simulation standpoint. So basically what we have done here today, so basically we mentioned some of the field experiments we have been doing. So basically, we showed some road subgrade type of applications, and also showed them 4 projects with hot mix or warm mix asphalt rubber in the pavement and main layer projects. So most of the project we are dealing with basically are either reconstruction or overlay. So far, the project all looks pretty good. So basically, we don't really see any distress or any major issues. And also this year start to deal with some major application in the chip seal with rubber asphalt. And also I should briefly show you some of the laboratory and the computer modeling research work we have been doing. So far, I think we are very happy with the work we have been doing. And of course, I'll be happy to know what what I can work with you folks, and if there are anything along the roads. So basically, during our research and the development, we are really, I think it's really good for us, including students, to work with other partners, local partners, state partners. And so basically we're working with, biking associations, road commissions, and material suppliers, contractors. So basically it's pretty fun experience to work with the group. And you can see we got an award from the county road associations for the project we did here. And another project, basically you can see is we are working as a big team. So basically work with all kinds of parties together. This one was in the Kalamazoo project. We won the award from American Public Works Association for 2019 project of the year because of the high concentration of rubber and also the chip seal application in Kalamazoo. And of course, there are a lot of things we are planning ahead. So basically, we are going to refine our pavement design and the materials innovations, right? Because there are a lot of things, new things coming up. And so we are trying to acknowledge those presents and those trends. We have to, make sure the pavement materials are meeting the heavy loads, meeting the electrical vehicles and all those kind of developments. And another big thing we are doing here is, we are always considering new materials, new applications, and we are trying to save the materials being sent to landfills. And we're also trying to recycle all kinds of materials recyclables. For example, like plastic, glass, roof shingles, and other type of materials. So basically, we have been doing this one over the years. And with that, I think that's all I have.